So hello guys, welcome to my YouTube channel AV Classes. So our next topic in ray optics is the spherical lenses. Now as we know, spherical mirror is a piece of reflecting surface. That is, the spherical mirror is based on phenomena of reflection. Whatever is the light incident on it get reflected. But spherical lenses is a piece of refracting medium, and whatever is the light incident on it get refracted. See, spherical lenses is bounded by the two refracting surfaces, out of which one surface must be curved surface. And we know spherical lenses are widely used in our daily life, like in spectacles, telescope, microscope, all these things. Now, spherical lenses are of two types. As you know, one is convex lens, another is concave lens. See, this is convex lens in which the middle portion is wider while the edge portion are thinner. This is convex, and this is concave lens, in which the middle portion is thinner and edge portion are wider. Now this, when the rays of light incident on this convex lens, its ability that it converts all the rays of light incident on it to a point called focus, while these rays, when parallel rays incident on this concave lens, the rays of light get divergence. That's why this this lens is called converging lens, and this lens is called diverging lens. Okay. Now, whatever the parameter we defined in spherical mirrors, like pole, radius of curvature, center of curvature, all those things are also defined here. But instead of that pole, we have optical center. Here, this lens has two surfaces. So it also had two center of curvature, two focal length, two radius of curvature, and one principal axis. Okay. See, this is convex lens. Okay. Now this will going to be the optical center P. No, A, B, C, D. Now for the curved surface ABC, it is a part of a reflecting surface, so it will has one center of curvature here. Let's say C. And for this, another center of curvature is here. That is for ADC, center of curvature is this one. And we know focal length is half of this center of curvature. So this is, so two focal length, two center of curvature. This is optical center, and this is the principal axis. So these are the basics things that you had already known. Now the most important thing is that we have to study about the refraction at convex spherical surfaces. How refraction undergoes, or how refraction perform throughout the uh, convex surfaces. See, all the rules we defined in spherical mirror will be the same here. Like, all the distance has to measure from the pole. So here the all distance has to measure from this optical center. All the distance which is measured in the direction of incident ray will be taken as positive. The same concept applied here. Okay. So starts this thing. Consider a convex surface. This is convex surface. Now this will not going to be a concave convex mirror. This will going to be a convex lens. Okay. So this is a convex surface. Now when the rays of light, let's suppose this is the object. In here we consider the point object, and a single ray of light incident on this convex surface. Then it undergo refraction by angle of refraction r, and this is the angle of incidence r. I. This is the rarer medium, this is the denser medium, refractive index is mu1, this is the mu2. Now we are going to find the relation between these two, refractive index and also between this radius of curvature, object distance, image distance. See, from Snell's law we have only knowledge about this thing. Like if the light travel from rarer medium to denser medium, then we know 1 mu 2 is what? Sine I upon sine. Okay, 1 mu 2 is what? Sine I upon sine R. But it does not give any information about the image distance, object distance. Okay, that's why we have to study this topic in order to find the relation between these various parameters. Okay, so the one ray is this one and the other ray is this one, which is passes through this optical center and undergo undeviated. The image formation takes place here because one ray is this one and one ray is here. We will meet at this eye. Okay, now this incident ray, this refracted ray and this normal which is passing through center of curvature make angle alpha, beta, gamma respectively with the principal axis, and this angle, see, this light rays are we use generally are paraxials, so that the angle formed by this light rays with this principal axis will be very small, due to which we are able to take the sine and tangent of these angles equal to angle itself. Okay, so these are the things. Drop a perpendicular NM on this principal axis. Now for the triangle OC and N, this I is exterior angle, so this I is equal to sum of opposite interior angle. I is what? Alpha plus gamma. First. Second is that this gamma is equal to R plus beta. Gamma is equal to R plus beta. So R is equal to gamma minus beta. These are the two things. Now, next we are going to find out the values of these angles. So, in triangle ONM, this tan alpha is what? Perpendicular upon base. So perpendicular is NM and base will be what? OM, which is equal to NM. Now here this lens has thin aperture, due to which this M and P are so close to each other, and we consider OM is equal to OP. Okay, so this OM is what? Equal to OP. Next is tan alpha is okay. Next is in triangle what? NMI. Okay, NMI. Tan beta is what? Tan beta is what? NM upon MI, and MI is almost equal to PI. And in triangle NMC, tan gamma is what? Tan gamma is equal to NM upon, see, tan gamma is what? NM upon MC, and MC is almost equal to what? PC. Okay, see, we already told you that these angles are very small, so we can write tan alpha is almost equal to alpha, tan beta is almost equal to beta, and tan gamma is almost equal to gamma. So this is almost equal to alpha, this is beta, and this is gamma. Okay, so these are the things. Now we use Snell's law here. Then this is first medium, this is second medium. So 1 mu 2 is what? Sine I upon sine R. Now this 1 mu 2 is what? Mu 2 by mu 1? Sine I upon sine R. Then mu 1 sine I is equal to mu 2 sine R. This is one relation. Now the sine of this angle of incidence and angle of refraction are equal to angle itself. So this is equal to mu 1 I is equal to mu 2 R. Now put the value of this I from here, R from here. Okay, I'll write here. Then mu1. I will put the value of I from here. So I is equal to what? Alpha plus gamma, and mu2 is R is what? Gamma minus beta. Okay. Now we already have value about of alpha, beta and gamma from here. Alpha, beta and gamma. So put out here. So this mu1, alpha is what? Nm upon op, plus gamma is what? Gamma is Nm upon Pc, which is equal to mu2. Gamma is what? Nm upon Pc, minus beta is what? Nm upon Pi. Now this Nm will be cancelled out from both sides, and we are left with mu1 1 upon op plus 1 upon Pc, which is equal to mu2 1 upon Pc minus 1 upon Pi. So this is what we had left. Now the next thing is that, see, oh, this OP is the what? We have figure here. This is P. This is pole. This OP is what? This is the image object distance. This PC is what? Radius of curvature. This is the object distance. And what is PI? PI is what? Image distance. That is V. Okay. Now this OP, that is the object distance, taken to be negative because it is left of the that convex surface. PC is taken to be positive and Pi is taken to be positive. Then I'll write here OP is what? Minus U. PC is what? R. And Pi is what? V. Okay. Now see, take this mu1 upon Pc to right hand side and this one to left hand side. Then we are left with mu1 mu1 upon OP, and then plus mu2 upon Pi is equal to what? Mu2 minus mu1 upon Pc. This is what we had left. Now this mu1 OP is what? OP is minus u plus mu2. What is Pi? Pi is V, which is equal to mu2 minus mu1. And what is Pc? Pc is R. So this become equal to mu2 by V minus mu1 by U is equal to mu2 minus mu1 upon R. So this is the relation between the object, image, radius of curvature and the refractive index. See, when the object placed in rarer medium and image formation in denser medium, then this is the form of the formula. When the object placed in denser medium and image form in rarer medium, then simply you have changed what? Mu1 to mu2, that is mu1 by V minus mu2 by U is equal to mu1 minus mu2 upon. This is the only change, that is you have to replace mu1 by mu2. Okay, this is for rarer to denser and this is for denser to rarer. So that's all we have. In next lecture we are going to discuss we will discuss about the lens maker formula, in which we find the relation between the focal length and this refractive indexes between the two media. Thank you.